Automation Fair. It's November 18th through the 21st in Anaheim, California. Registration is now open. It's 4 days, so no longer is it 2 days of PSUG and 2 days of Automation Fair. The expo floor, I believe, is going to be 3 days, and there'll still be a PSUG type component, labs, like you're used to seeing both in Automation Fair and previously from Rock Live. And there will also be quite a few offsite tours for various industries. They've kind of mixed it up. I think there's pharma, food and bev. I can't remember the other one. I think there's a process facility. I can't remember if it's chemical, but those are all available when you register via the QR code or via Rockwell's website. This is what the overall agenda looks like. Again, the expo will be open for about 3 days to walk the floor, and that'll be Tuesday through Thursday. There's an advanced training pass that gives you additional access to the hands-on labs and professional development hours or CEUs that you normally or you used to see with Rock Live. So that is an additional cost incurred, about $1,000 more than the regular registration pass for the general access. And our presenter today is David Newt, and I'll let him take it away.
All right, thanks for that. And that was Brian McKeska. So thanks for that, Brian. And today I will be talking about process solutions overview. So this is a real quick agenda. So when we talk about process solutions, we're really talking a lot about PlantPAx, but there's also a lot of the tools and the parts associated with it, like the hardware and the libraries, and we're going to talk a little bit about architectures. And then at the very end, we're going to kind of give you a sneak peek at something called Logix SIS, which we're pretty excited about. It's not quite released yet, but we feel like it's close enough that we can kind of start to get the word out. So we'll finish up with that today. So, PlantPAx, I think a lot of us know what it is. Rockwell add new things to it, new functionalities, sort of the new stuff with 5.3, the release that is out now, has to do with some of the new edge connectivity and a data platform called Mosaics. And so with the connectivity, FactoryTalk Optics is now, this is the first time we've mentioned optics with PlantPAx, and we're pretty excited about that. And there's going to be more to come. So I will be talking a little bit about optics today. This is a little more detailed look at the roadmap for this year. Of course, the green items have been released. And so I think a couple of highlights with 5.3 on the networking side. PlantPAx is now up to speed on the Stratix 5200 access switch and the 5800 switch that kind of replaces the 54. So that's good. Also, another highlight of 5.3 is an update to the Intelligent Electronic Device Toolkit. So and really within that, the exciting new part about that is the extensive support for the IEC 61850 protocol, and we've got a couple of slides to talk about that in more detail. We'll kind of leave, so there is another kind of release scheduled. We're not going to really talk about that since it hasn't happened yet, and these items are subject to change. If you are alert and you see FactoryTalk Optics faceplates on there, that's been delayed a little bit, so we're not going to talk about those today. Although those are definitely on the roadmap, and we're looking forward to when those come out. So with 5.3, just an overview of some of the software versions to keep us straight. It is Logix Designer version 36. 36 has been out for a little while. But this 5.3 release uses it. There are There is a version 37 that will come out in the future that will have some things that we'll talk about at the end of the discussion today. But 36 is 5.3. FactoryTalk View is version 14, and there's some important functionalities that came out with 14 we'll talk about today. Also Historian version 9, etc. And some, you see the others there. And then at the bottom there was a recap of the PlantPAx version release versus the object libraries. And so there was a period of time back in 2020 where we had the release, the library and the release version were the same, but we've kind of drifted away from that already. But 5.2 is the library release along with 5.3 version. So we'll talk about hardware now for a little while. Of course, now we're really on year 5 of our process built controllers. So what we call the P controllers for short. So a quick overview of those. Again, those are both ControlLogix and Compact. Compact is a good solution for, our process OEMs or a very small system with not a lot of I/O, but high need for the process functionality. So, the process controllers do have the embedded objects. We'll talk about that some in a little more detail. There's more than just embedded objects, but also integrated heart. That's mostly with the Flex 5000. And also the graphic framework. We'll kind of give an update on that today. The graphic framework is in Vue SE, but it's all linked together with the process controller objects and a few other things. Cybersecurity, I don't think we have a slide on it, so I'll talk EN4TR Ethernet module with built-in SIP security. That's really a nice way to get some additional cybersecurity on your system without having to add anything more. So we are seeing the EN4TRs being used quite a bit in our new applications. When Rockwell has taken care of all the supply disruptions that we had in the last couple of years regarding that. So it's some new. So one thing that is new about Heart is the release of the Compact 5000 isolated Heart modules. Flex 5000 was the only platform that had highly integrated Heart. Now this is the second platform that Rockwell has added to that. So it's a nice small form factor with the with those capabilities to handle to be able to browse the Heart network inside of Studio 5000. Supports multiple versions of the Heart protocol. So and then that works with version 33 and later, so it does go back a bit. We probably expect that to see those sales ramp up. And again, the Flex 5000 is really becoming our probably most popular non-ControlLogix I/O for process. It's got great design ratings, temperature and hazardous environment ratings. It's got the full gigabit network. It also has the ability to do both DLR ring and PRP directly out of the network module, and it does safety. And so that will become important at the end of the discussion when we talk about some new things that we have going on with safety. So it really does quite a bit in one platform, and it's the same form factor as the old Flex. So this is kind of a recap of the different options. Flex 5000 is pretty much built out now. We've got a number of digital options. Of course, the analog with highly integrated Heart. There's an analog universal module, and then also some specialty modules that are good for process. The Heart, this was our first highly integrated Heart module. So it also, there's some additional functionality. I'm still searching for the use case, but you can do discrete points on the analog Heart module if you so chose. Maybe you needed 1 or 2 discretes and didn't have room to add a discrete module. You can do that in this module. And then finally, a couple of years ago, Rockwell released its latest hardware platform, and we call that Flex HA5000. And so we're in really the first major release. We have a lot more functionality to go, but it is a fully redundant at every step of the way IO. We also have it also has a fully universal IO capability. So that's AI, AO, DIDO, with one terminal block to handle it all. And of course, it does do our PRP and DLR support directly. It's got extended temperature range. So we're looking at this for larger systems or systems that involve an extensive amount of engineering in the front end where they don't really know what the IO count may be. So we can, with the universal module, you can really be flexible around engineering designs, and that ultimately saves money at the front end of a project. So that's kind of where we see this fitting in the portfolio. So moving on from hardware, let's talk about the application libraries a little bit. And these libraries really are the kind of what I consider the heartbeat of a PlantPAx system. They number one, drive consistency throughout applications. So where we see these used a lot is where customers really want to standardize not only on a hardware platform, but they want to standardize their application. You may have repeatable applications like gas plants and the oil field and the gas fields, where you've got maintenance folks that support multiple facilities. And if you have that same look and feel application at all those facilities, that just makes the maintenance and troubleshooting that much easier and more efficient for the user. So that's a really big driver in using these libraries. There's also development speed, increase efficiencies with deploying these. We have some customers that have saved a drastic amount of time going from one-off HMI PLC systems to using the libraries with FactoryTalk View SE, and they can drastically reduce the development time needed to roll out a new application. Support's important because, especially with PlantPAx, because once and along with the process controller, using these libraries are fully tested and supported by Rockwell. And so if you have a version 4 of the library and you want to move to version 5.2, there are easy ways to do that as long as you stay true to the version of the libraries. It becomes much more difficult if you have custom solutions and you don't use the libraries, and it makes the migration a lot more tedious and requiring a lot more interaction to get those migrations handled. So those are kind of the three main reasons why you would want to look at the libraries and implement the libraries. And plus they basically come with the software. So when you buy the controller, all the library instructions come with it. And when you get the View SE system, all the libraries come with that as well. So there's no extra cost to get all this functionality that you may not be using today. So the library, and there are about 5 libraries, but we've kind of dropped them into 3 different buckets. The process library is one we probably talk about the most because a number of the objects are embedded in the controller, and that's the process library. So those are your process functions, like your enhanced PIDs and permissive blocks and motor and valve instructions and those kinds of things. But also there's a number of device libraries. And so the device libraries would include support for all of our IO platforms. Also, we have a network library that supports all of our switches. And there's a power device library that includes a lot of our power devices like our E300s and their PowerFlex drives, those kind of things that really add a lot of value and functionality to an overall process system. And then finally, they're the machine builder library. So machine builders and OEMs that are trying to really want to lock down and standardize their code. There's things like ISA 88 state model instructions that help you if you're trying to consolidate and efficient, make your code as efficient as possible. Things like that that are really well suited for the machine type of skid applications. So let's look at the IO device library in a little more detail. So you can see all the different IO families supported. Pretty much every IO platform that we sell today has the supported IO device library. Anything from obviously control logics, but even the point IO and even armor block if you're in a different industry. And so these are all in the faceplates. No add-on instruction required. They will interface directly to the diagnostics that are built in to the hardware when you go configure it. In Studio. So real efficient. Really the best way if you really want to include diagnostics in your application. This is the best way to do it, and that without having to write anything custom in your HMI. Then, of course, the process library, really the heartbeat of PlantPAx. We talk a lot about the embedded instructions, but there are also a number of add-on instructions that are available in addition to just what's embedded. And so it's important to understand that. So if you add the embedded instructions and the AOIs, you're up probably 50 or 60 different instructions that you can use that are process-based, along with the faceplates that are in VUSE. Another thing to understand is not every process application uses a process controller. So there's a lot of applications that still use the standard controllers. And so so today, the way we support that is with our 4.1 release of the AOIs. So those were released a number of years ago, but they are still active. They're still supported today, and they will be supported for quite a while down the road. And those are the 4.1s are for applications that are not using the process controllers. So that's certainly a valid way to implement to use the process libraries today. And then a little deeper into the library, in the process library, what's in it. So there's a lot of different things. There's some, of course, there's the AOIs for the P controllers, but there's also all the displays and global objects that come with VUSE, and they get automatically installed now with the new version of SE. And the other thing that is just to note is the Panel 5000 does support this process library now. That's a new thing that happened a few months ago. But there's also a number of template files that we'll talk about, the graphic framework that also come with it in SE. And in addition to some canned reports that are in the SQL services report format. So if you are using SQL Server, there's probably about 30 or 40 different canned reports that you can get access to that come with the download itself. Then the network device library. So this is the library that supports the Stratix switches. We got a recent refresh of this that's now available. So this includes all of the new Stratix switches, like the 5800s and the 5200s, as well as the ones that have been out for a while. There's a new PRP monitor. So if you've got a parallel redundancy protocol network design in your system, there's a specific PRP monitor that monitors the status of those in case one of the LAN A or LAN B was having issues. And you can see this platform is supported in three of our different HMI offerings, including ME. What's not on this slide is this library is also newly available in FactoryTalk Optics. So that's 4 HMI platforms you can use this. So it's really a great way to have network diagnostics available on the HMI. This is really a great way to do that. And another refresh we've had is the what we call the Intelligent Electronic Device Library, or the IED library. So this library is specifically for, I would call, like switchgear type automation systems, where you've got electrical protection devices like the smart relays. What's important, a couple of important things about this library is, number one, it supports a lot of non-Rockwell specific devices. You can see the faceplate there is actually a Schweitzer or an SCL device that it's connected to. And also, we've added extensive support for the protocol that's used a lot in switchgear automation, which is IEC 61850. And that's through a ProSoft module. And so this slide kind of gives you a little more details of what this library supports, the specific devices. So you can see all the Schweitzer relays and communication devices, as well as the multi-lens stuff from GE, and then ABB and Rockwell as well. So this is a nice addition, as well as the IC 61850 capability, which I don't think we have a slide on it, but the IEC 61850 supports both MMS and Goose protocol. And so if you've got a Schweitzer system, they do a lot of Goose protocols, so that we do support that with our 61850 module. So kind of moving on from the libraries, we'll talk about the graphics framework a little bit. So with version 5.0, is when we first released this, but just kind of a refresher to and really what we've done additionally. In the past, we just had the framework displays were imported into the VUSE. But what we've done with this release is we actually added a new application called the Framework Builder, so you can kind of graphically place your displays, in a framework, and kind of build it graphically instead of kind of ad hoc inside of VUSE. So again, this is a step forward, and let me take a step back a little bit. What we call our graphic framework. In industry, it might be using different terms. So the ISA 101 is another term that's used. Another term would be high performance graphics. Some people call it the operational efficiencies and lowering of operational risk using these. But essentially, we call it the graphic framework. So within our graphic framework, we have essentially 4 different levels of display. So you have a level starting, and this was the updated slides. That's corrected slide. Level 1 is your graphics overview. So that's your overview screen. So really, the idea being that this screen, if you had an operator station with 4 monitors, say, this overview would probably be one of those monitors that's always displayed. And if you notice, there's not it's not a PNID redrawing of what your process equipment looks like. It's a lot of data that you can see. So instead of graphics, you're going to see a lot of trending, because the research that ISA did discovered that longer term trends tell a good story about what's going on in your process. So you see the trending there. And that's going to be a real-time trend, but that could be an hour, 6 hours, however fast your process goes. So if you see something drifting, an operator can pick up on that maybe before an event happens. So you see a lot of graphics on the level 1. The level 2 is kind of your main control. So you do dive into the process and see some of the equipment. So you can see some equipment there, but again, you still see trends at this level. And then let's say the level 3 detail display might be some motors, valves, etc. inside of a piece of process equipment. And again, so you'll actually probably turn on and off valves on your detail display screen. And then of course you have your faceplates. So the faceplates are really used for detailed operation. Also, they're used for maintenance and engineering. So in the engineering side, you may want to be tuning your loop, use a faceplate to do that. Or if you were going in and making changes or diagnosing a fault or an interlock, you would go into your faceplates to do that. So that's basically the graphic framework in a nutshell. So some more tools. One of the things, most important tools that we have in PlantPAx are tools that allow us to do bulk modifications, bulk adds, bulk changes to alarms, etc. So those tools are available. Those are separate downloads. So those tools, allow you to do things like change alarming, not one at a time, but groups at a time. You can also build your historian configuration, whether that's adding individual points within an asset framework database. So that's all things you can do in a bulk. And then sometimes, on a startup, a lot of the ranges, sometimes alarm ranges might change, or even equipment gets replaced, and some of the engineering ranges could possibly change. The bulk modification tool allows you to do that in a bulk without having to do it one at a time. So those tools are available inside PlantPAx. So there's another screenshot of the configuration tool, and this is basically allowing you to change a lot of alarming inside of Excel. So you do an export, you go into Excel, make your changes, import it back in, and you've made a lot of changes. PlantPAx systems that were using older libraries. Every version of PlantPAx library is a little bit different. And so so applications that were using an old library, if you wanted to upgrade to a current library, you use this migration tool, and it helps streamline that migration process extensively. And especially now with the version 5 and later, certainly the embedded objects are locked down, and so that makes the migrating much more smoother. So those tools are available. There's also something called an event queue, and for applications that use SQL Server a lot. So if you're using the SQL Server reporting services, and I mentioned earlier, there's about 20 or 30 different canned reports that are available for download on the PlantPAx side. The event queue, so those are canned, and so if you can use those, great. But if you need to kind of write a little more customized reports based on custom events, so it allows you to create an event, and then graphically in a GUI, and then what that does is when you go through the wizard that you can see there, it eventually will create a new report into SQL reporting services, and then make that available to you. So that's a reporting option that's available. The other thing that's new with FactoryTalk Services 6.4 is what we call an enhanced system status portal. And so what that does is that takes all your factory talk events that are get stored to a log file, and it kind of gives them a dashboard feel. So all these events that get captured, if you had these dashboards are available through a web browser. So you can see there, you can look at it kind of as in a storyboard type of format that you've seen used a lot lately in some of the new analytic tools. That's now available with Factory Talk Services 6.4. So that's a nice way of consolidating and kind of organizing all those Factory Talk events that get logged in the system. So after the tools, let's talk about architectures a little bit. And one thing that Rockwell's done recently this summer is they've published an extensive amount of kind of approved and recommended architectures. And it's not just PlantPAx. There's a number of PlantPAxes, but there's also a lot of the software, for example, Asset Center, Historian, also has a number of reference architectures that are real nice. And so I thought I'd take a few minutes to kind of explain. This is considered a medium size, but in our market, I think this is probably pretty large PlantPAx system, although we can certainly get larger. This architecture here is a 5,000 IO point system, but also has 30 OWS clients, which is quite a bit of clients for our applications in our space. But this gives you an idea of, and this would be installed in a virtual server environment typically. So I'll go over some of the servers here, and so you can see on the top left corner of the diagram, you see those are the clients. So those are, in this case, these are thin clients, and so the thin clients are gonna be in a virtual server environment. But the thin clients will typically run on Rockwell's thin client hardware that we sell. We have a lot of different varieties. So you can have multi-monitor thin clients, you can have single monitor thin clients, etc. And then those, and so in this case, there's a couple of different locations where you have them up to 30 clients. And so the clients actually, in this case, it's a thin client. So the actual client application has to run somewhere. And so that's where you go down to the bottom half and you see kind of in the middle, you see the app server OWS with a X4 next to it. So Rockwell recommends no more than, if you're running a virtualized environment, an app server OWS is essentially the Rockwell, the Microsoft server that supports all the instances of the thin clients that are running. So if you see there's 30 OWS clients, but there's actually 4 OWS servers that are running they're Microsoft remote desktop services that are supporting all the different remote clients. Well, Rockwell also recommends that you have kind of an N+1 redundancy on the OWS servers. So if you have 30 clients, instead of just having 3 OWS servers that are supporting 10 clients each, we recommend that you have an additional client to share to do load sharing, but also in case one of the OWS virtual machines were to have an issue, you still have 3 there that will handle all 30 clients in this case. So that's the OWS server. And in this application, there's actually 5 engineering workstations or EWSs. And so there's a separate EWS app server that hosts those engineering workstation thin client applications. So right next to the app server OWS, you have 2 EWSs. And so with an EWS, Rockwell recommends no more than 5 EWS instances running on an EWS server. So we have 2 here as an N+1 redundancy. So in case one of the app server EWSs were to have an issue, you won't lose your EWS thin clients because they'll just shift over to the other one. So that's kind of a little bit background there. On the top right, you have some of your application virtual machines. So you have a historian virtual machine. You have an information SQL, and the SQL server there on the top right, that will run SQL Server. And so that's where you could, if you're doing reporting, you could set the reports there. If you had an asset center system like this does, you could use the SQL Server and the InfoSQL virtual machine to run your SQL connection to Asset Center. If you notice, the Asset App Server does have the Asset Center server and in this case, an agent. So those, we typically keep those separate from the SQL Server. So that's the application servers on the top right. And then on the bottom left, the PaaS server. And a lot of times it's not listed here, it's listed as an option. We usually have two PaaS servers, and that's where your View SE servers sit. So for View redundancy, you would have two PaaS servers running identical View SE server applications, and then they'll be in lockstep and redundancy, so you won't lose any HMI data that way. You also, with a system this large, any system approaching 10 clients is required to have a domain controller. And a lot of times it's not on this diagram, but sometimes we do add redundant domain controllers, and that can host not only the domain controller, but it can also host a time master. If you're doing time synchronization throughout your application, we can put the time master there in the domain controller. Actually, it does show two instances there, two domain controllers. That's pretty much it I wanted to talk about. And so these architectures are actually characterized and tested by Rockwell. So Rockwell actually takes the time to set these architectures up, tests them in their lab, and then publishes this. So to help you design a new system, we know this architecture works. So moving on, so we're going to talk a little bit about optics. And so optics, is Rockwell's newest visualization and data aggregation platform. So optics really fits well and complements View SE systems. And so there's a few use cases we're going to talk about that would apply to process that can be helpful, as well as remote access. We'll talk a little bit about remote access as well. But specific to optics, so optics is a great dashboarding tool. Optics is built on OPC UA. It also handles some other connectivities that traditional process systems do not handle, like MQTT and some others. So there's a lot of nice use cases around getting data that normally wouldn't go into a process system into it, and we would typically do that with optics. Optics also has a really nice basic reporting tool. So if you just want to create PDF reports, optics is a great tool for that. Very easy, and with its extensibility and openness, optics supports C# script as well as Microsoft.NET libraries. So you've got access to a wide variety of different dashboarding type tools that are available free in the marketplace. And we have some customers that have used some kind of dashboarding shareware you can get from Google and other vendors that really complement and make dashboarding kind of a really kind of sizzle, nice looking graphics. We'll talk about a few of these use cases with that pertain to optics, and we'll introduce remote access a little bit. So if you had the need to pull in a lot of OPC UA data, we have a number of ways to do that these days. But with specific to optics, optics is built on OPC UA. So, and optics, what's nice about optics is optics gives you the ability to run the application in a number of different platforms. So there's an optics panel, which is a lot like an operational panel, similar to a panel view. You can grab data through the panel. You can also use a traditional industrial PC. You can also put optics inside an embedded module in a ControlLogix chassis, an embedded compute module. So there's a lot of different ways to grab that OPC UA data through optics, and then again display that data through our FactoryTalk links into VUSC. So that's kind of the OPC example. If you were getting into MQTT and some of the Internet of Things type of devices, optics handles MQTT directly. So it's a really nice way to pull to connect analytics in the cloud via MQTT, kind of out of the box basic functionality. So this is an example of using MQTT inside an optics box. And so, again, that optics box could take many shapes and forms. Optics, not only does it support Windows OS natively, it also supports Linux. So Linux boxes, Linux single board computers, those are something that we can run as well with optics. So the reporting I mentioned, it's really nice. So the optics has a really simple PDF report generator inside of it, and so you can take this data, whether it's from OPC or MQTT or Ethernet IP, and consolidate all that different data into a single report, and then create your PDF reports that way. Really, and a really cost-effective way to do it as well. So that's an example of kind of consolidating and reporting. It also supports ODBC. It's been around for a while. So if you wanted to push the data up to SQL Server, you could do that through ODBC. So that's optics. Now we'll talk a little bit about FactoryTalk Remote Access. So Remote Access is a relatively new product from Rockwell. And this sample architecture is kind of what I would call a traditional remote access architecture. We've had a lot of success with the E1 product over the years, and this is kind of similar to that, where you have a hardware device. Rockwell's is called the Stratix 4300 remote access router, and so that's basically a VPN tunneling device that will connect your industrial network into a VPN tunnel to maybe connect to a FactoryTalk hub to do some things through the cloud. So that's kind of the traditional architecture. Remote access, I think, was maybe a little more interesting is Rockwell is starting to embed the FactoryTalk remote access in some hardware platforms. So, for example, an optics panel will have a level of remote access assigned to it. So you can, without another piece of hardware, a router, you can connect to an industrial PC. It will have the remote access capabilities built into it. You can also, this same remote access functionality can also be used in a ControlLogix chassis compute module as well. So you could build kind of a remote access connectivity directly into your ControlLogix chassis, so without the need for an additional piece of hardware in the panel. So that could be beneficial as well. So with FactoryTalk View SE version 14, really one of the most exciting pieces of that new release was support for something called InfluxDB. InfluxDB is a time series data logger historian that's built into View SE server. So this will allow you to log process data on a time series basis without having to use a separate FactoryTalk historian. So and this InfluxDB is not licensed via tag count, but it does run on your View SE server. So this is a nice addition. So if you had a small amount of data that you wanted to store that was processed data, this would be a nice option to look at without having the expense of a dedicated historian if you feel like that was overkill. And what's also nice is, it's currently supported in View SE. There's also plans for to add InfluxDB into FactoryTalk Optics as well, but that's at a later date. So we're pretty excited about having this in View SE. And then also along the data management side, Rockwell has released something called FactoryTalk Data Mosaics. And Mosaics is really what it does is it takes all your typical process control data, whether it's from PLCs, servers, etc. And Data Mosaics makes that data available in a cloud, analytic cloud, and allows you to apply a number of analytic tools to do data aggregation at the cloud level. So, so this is an exciting thing, and it's also there also is a private cloud version available, though typically it's done as a software as a service, pre-existing cloud, but this is called Data Mosaics. So finally, this is kind of in addition to PlantPAx. This is maybe the first time we've really talked about this introduced this at a broad level with our customer base. Rockwell is releasing something called Logix SIS. So Logix SIS, as you can see there, is a controller redundant, SIL rated system based on the ControlLogix platform. So you can see, I thought I got some graphics there. You can see it's ControlLogix based. You can see the red controllers there. Those are GuardLogix controllers. And you can see that the I/O is the Flex 5000 GuardLogix I/O. So you see the reds there. That signifies GuardLogix. That signifies up to SIL 2 and SIL 3. So so here's kind of a recap of what we've done in the past. So the current architecture, there's more than one, but this is just one typical SIL 2 current architecture with the ControlLogix. We used standard ControlLogix controllers, simplex or redundant. And then we used standard I/O. So the I/O initially was ControlLogix I/O, but then at a later time, we introduced Flex I/O, and also kind of the final release was the 1715 redundant I/O. And that's probably where we have most of our installations, although we don't have a graphic for it here. So that's our current system. Now, the limitation with it was only SIL 2. We could not get to SIL 3 using our standard hardware. So with InterLogix SIS, using the GuardLogix 5880 controllers or the L8 GuardLogix and the Flex 5000 or the 5094 safety I/O, we can now get SIL 2 or SIL 3 certifications on a ControlLogix or a Logix platform. So that's the big difference. So today, or when it gets released, it will be the Flex 5000 will be the I/O that's required, as well as the L8 GuardLogix controllers. So here's my graphics. So and again, this is going to be version 37 of firmware, which is not released yet. So there's the idea, traditionally we had a safety partner and a Logix and a guard Logix controller in the one chassis. Now what we can do is we can take two guard Logix controllers, put each of them in their own chassis, connect it with an RM2 module, and that will reach SIL 2 or SIL 3 certification. So that's the big step that we've made, and we've been working on this for quite a while. So we're really excited about this. The first release will be Flex 5000. In the future, we will support the Flex 5000 HA, and you can see this is in a PRP network environment with this. We also would support DLR with this as well. So to recap again, it's the L8 guard Logix controllers in a traditional redundant architecture. It will be version 37 of Studio 5000, coupled with the Flex 5000 safety guard Logix IO. So again, version 37.011 would be the firmware kit. So it would be a similar redundancy firmware kit that you're used to with the standard controllers.